up next we have Cyril Dell'Eva who's doing he's a postdoc fellow at the University of Pretoria. And yes, I think we look forward to hearing what you have to say. So over to you.
Okay. Thank you. So I just share my screen. Is it okay? Can you see it?
Yes, looking good.
Yes. Okay, so anyway, good afternoon, everyone. So I'm going to present you a paper entitled Economic Stability in Small Open Economy Under the Shadow of International Financial. This is a co-written paper with Nicolas Vieggi. So the idea and the motivation of this paper comes from the fact that policymakers in emerging economies worry about stabilizing capital flows, and even more after the 2008 crisis, in the sense that after the crisis, large economies began to massively use quantitative easing policy, which have flooded emerging markets with liquidity. And these capital inflows could be destabilizing for small open economies. However, if you stick to the uncovered interest parity, this destabilizing effect of capital inflows should disappear in the sense that the UIP states that the IM currency tends to depreciate. So the depreciation of the exchange rate, of the expected exchange rate, should cancel this destabilizing effect. But since the famous paper of Pharma in 1984, we know that UIP doesn't hold in the short to medium run. And many other studies have shown that the IM currency tends to appreciate instead of depreciate. So this issue of destabilizing flows is still highly relevant and, in my opinion, needs to be treated. The point is that many macro models still assume UIP, and in this paper we argue that we should relax this assumption in macroeconomic models, and we want here to present a tractable macroeconomic model with deviations from the UIP. So when you talk about UIP and international finance, the important trend of the literature is the microstructure, in the sense that it began to question the continuous use of the UIP in the beginning of the 2000s, and this literature shows that short to medium run exchange rates are driven by position and risk in the foreign exchange market. The paper of Gabe and Maggiore is really interesting in the sense that it kind of reconciles the macroeconomic literature with this microstructure literature, in the sense that they propose a way to model the exchange rate in which the exchange rate is driven by position and risk in the foreign exchange market as well. So the aim of our paper is to introduce this short-term deviation to medium-run deviation from the UIP in a tractable macroeconomic framework. I mentioned Gabe and Maggiore here, so I guess you understood that we will model the exchange rate in a similar way as what they did. So concerning the paper itself, we use a micro-funding mechanism small open economy model, in which, as I just said, the exchange rate is driven by position and risk in the foreign exchange market. Then we will simulate demand and supply shocks with different monetary policies in order to investigate which monetary policy is the most able at stabilizing the economy in a risky environment. Then we estimate the model with Bayesian Markov Switching for South Africa. So this part is a work in progress. We do have results quite interesting, but it clearly needs more work. So I'd be glad to have feedbacks or ideas on this part of the paper. Anyway, what is important in this estimation is that our model will switch from a low volatility regime to a high volatility regime according to the risk. And we proxy the risk by the VIX here, meaning that when the volatility of the VIX will be high, we will be in the high volatility regime, so in a kind of crisis regime. And then once we estimate the parameters, we will simulate again supply and demand shock with these estimated parameters in order to see what will happen in South Africa after demand and supply shock from our model. Okay, the contribution of the paper are the following. First, we do propose a tractable macroeconomic model with realistic deviation from the UIP. And in my mind, it could be really relevant for policy making. Then our model is able to reproduce the depreciation observed in indebted countries and the appreciation observed in countries receiving capitals. Then our model shows that the monetary policy is able to mitigate the stabilizing effect of capital flows. And our results suggest that an optimal monetary policy appears to be the best at stabilizing those small open economies receiving stabilizing capital. At last, in our empirical estimation, we show that this optimal monetary policy is not sufficient to reduce the volatility of the exchange rate after a shock in South Africa during crisis period. So this result, preliminary result, suggests that maybe South Africa would need more tools than the interest rate in crisis periods to tackle this issue of destabilizing capital. Okay, so now let me talk about the model. I'm gonna present it quickly with the less equation as I can. So we have a small open economy which trades with the rest of the world and has access to international financial markets. In the model, there are financial institutions and they act as intermediaries in the international financial market. One really important point here is the fact that these financiers have a limited ability to bear risk. And from this limited ability to bear risk, financiers would require a premium in the sense that when they hold a risky currency, they need to be remunerated for holding the currency. And this comes from this risk-bearing capacity. So now I'm going to give you a really simple example in order to understand how the exchange rate evolves in the model. So the small open economy finances its imports by borrowing to international financial markets. So in such a case, what is going to happen is that households will sell the domestic bonds labeled in domestic currency. So obviously the financier will take the opposite position as the households. And so it will be long in the domestic currency. So what happens to the exchange rate here is that it's going to depreciate in the first time and appreciate further, because the future appreciation will remunerate the financier which is long in the domestic currency. And what is really important here is that the higher the risk, so the lower the financial risk-bearing capacity, the larger the depreciation in the first time and the appreciation further, in the sense that the larger appreciation will allow to remunerate the financier more for holding the currency, the risky currency. So here we clearly see that the movement in the exchange rate in our model are totally related to this financial risk-bearing capacity. So now how do we model it? I go quite fast here because it's really exactly the same thing actually as what Gabi and Marjorie did in their paper. But if you have questions in the end, no problem, I can explain more. But the global idea is that on their side, households optimally value their currency trade, of course. But what matters here is what the financier does. The financier maximizes the value of its firm, VT, where RT is the domestic interest rate, SRT the foreign interest rate, epsilon T is the nominal exchange rate. An increase in epsilon T represents a depreciation of the domestic currency. And QT here is the financial demand for the domestic currency. So the financier is going maximizes this function under the constraint 2, where gamma is really important because this is the risk-bearing capacity. So a higher gamma means a higher risk, So with a higher risk, the value of the firm of the financier needs to be higher. And QT over ET, QT square story over epsilon T is the total divergence table, not easy in English. Okay, so in the end, substituting equation 1 into equation 2, and assuming that beta is equal to 1 over R, we get the aggregate financial demand for asset. And what we can say here first, when the current exchange rate depreciates, the demand for asset of the financier increases because the expected exchange rate is going to appreciate, which increases the return. When the domestic interest rate increases, it increases the return, so the demand increases. Opposite for the foreign interest rate, obviously. And when gamma increases, the risk increases, so the demand of the financier reduces. Then the equilibrium for demand for the domestic currency is set on international trade markets. So this equation, Xi is represents export value. We assume it equal to 1, similarly to what Gabbian majority. Epsilon T is still the exchange rate. Nu T represents the import value, and QT is still the demand of the financier. So what is important here is the fact that when the import value increases, the demand of the financier increases. Why? Because as I said in the beginning, when imports value increases, the financier is long because the country borrows. So the demand of the financier for the domestic currency increases as well. Then after some calculation, we get the expected depreciation in the domestic currency, which is the equation 5. And it depends on the interest rate, the risk-bearing capacity, and current and expected import value. So I put this equation in log in order to be clearer while explaining the link between the variables. So first, what you see is there are two opposite effects of the domestic interest rate, RT. First, an increase in the interest rate is gonna depreciate the expected currency. The expected exchange rate is gonna depreciate. And this is totally related to the UIP use because when the interest rate goes up, the expected exchange rate should decrease to equate return. So when there's no risk, we have only this effect of the interest rate. The other effect related to gamma is due to the fact that when the interest rate increases, it is the incentive of the country to borrow from abroad increases as well. So the financier is going to be long in the domestic currency, and the domestic currency is going to depreciate today to appreciate further in order to remunerate the financier. We have the same impact on import values, the one I'm talking since the beginning. When import values increases, the financier is long. So we have a depreciation followed by an appreciation. And for MT+1, it's the same, but in T+1. When import value increases in T+1, the exchange rate in T+1 depreciates to appreciate further. Okay, so the other equation of the model are quite standard, so I go really quick through them. The first one is the CPI inflation, and it depends on the PHT, the domestic inflation, and ET, the nominal exchange rate. UT is a shock. So obviously, when the domestic inflation goes up, the CPI inflation increases as well, and a depreciation in the domestic currency increases the CPI inflation. Alpha represents the openness of the economy. So the more the economy is open, the more the depreciation will increase the CPI inflation. Concerning the domestic inflation, this is the following the Phillips curve. It comes from the micro-funding model, and it's really a standard equation. So the domestic inflation depends on the expected domestic inflation. the output gap, and a shock. That is really standard. I don't have a lot to say about it. The highest curve also comes from the micro-funded model and is quite standard. The only innovation here is that we have an effect of expected changes in the exchange rate, and an expected depreciation here increases the output gap. Why? Because this expected depreciation means that the financier was short at time T, so that there was less import, which has a positive effect on the current account and on the output gap in the end. Okay, so we close the model with the monetary policies. We consider here two alternative monetary policies. The first one is a really simple Taylor rule in which the central bank responds to inflation and the output gap. Obviously, when we calibrate the model, gamma pi is equal to 1.5 and gamma x to 0.5. The alternative monetary policy is an optimal monetary policy in which the central bank minimizes the following loss function. So it minimizes the spread between the output gap xt and its target x bar, and the spread between pt and its target p bar. Psi represents the weight that the central bank grants to the output gap. Okay, then you minimize this loss function under the output gap and inflation, domestic inflation constraints, and you get the following reaction function. So obviously the central bank will increase interest rate after an increase in expected output gap, expected inflation, and expected domestic inflation. What is interesting here is that using an optimal monetary policy, the central bank is going to respond to expected changes and current changes in the exchange rate. So what happens here? An expected depreciation, as I said before, has a positive effect on the output gaps, which leads the central bank to increase the interest rate. Concerning the current exchange rate depreciation, it will directly increase the CPI inflation, which will also lead the central bank to increase the interest rate. So let me go now present you the results. So here we're talking about a demand shock. The blue line represents the optimal monetary policy, the red line, the Taylor rule. The dashed line corresponds to a low risk, and the full line to a high risk. So what we see here, first, after the shock, the demand shock, obviously the output gap increases, increasing domestic inflation, CPI, and the central bank increases the interest rate. What is interesting here is what happens on financial markets. So we have two channels here. First, the interest rate increases, so it increases the incentive of the domestic country to borrow from abroad, which will lead the financier to be long. But we have another channel. The output gap and the domestic inflation increases, which increase import value. So as well here, the country will borrow more from abroad. So the financier here is definitely long in the domestic currency. That's why we have a depreciation followed by an appreciation when we look at the exchange rate. And obviously, when the risk increases, the depreciation in the first time is larger than with a low risk. So we have a larger depreciation followed by a larger appreciation. Okay, so now let's just compare the two monetary policies when the risk is high. So what we see is that the optimal monetary policy is able to minimize the volatility of the exchange rate after the shock, which is quite nice. It's what we want, actually. So concerning the impact of the shock on the exchange rate, in a risky environment, the optimal monetary policy here appears to be better at stabilizing the economy. Now let's see what happened with the supply shock. So after the supply shock, the domestic inflation increases, cost increases, so the output gap reduces or is gonna reduce. So what happens here is that the reduction in the output gap will reduce import value. So now the financier will be short in domestic currency. So we have an appreciation followed by a depreciation. What can we say here? That you see for the Taylor rule, the appreciation is really large, which makes the CPI and the interest rate negative in the beginning. So once again, when the risk is larger, obviously the appreciation is larger, followed by a larger depreciation. Okay, so now let's compare again the two policies just with the high risk. And once again, we can see that the optimal monetary policy allows to minimize the exchange rate volatility after the shock. So once again, the optimal monetary policy seems to be the best at stabilizing the economy in a risky environment after the shock. But what matters for central banks usually is the volatility of the output gap and the inflation after a shock. So here in this table, I just report the volatility of the output gap and inflation after a demand shock and the supply shock under different monetary policy. Obviously, if we take the two shocks and average it, the optimal monetary policy will perform better because it's the calculation, it's mathematical. But if you separate the shocks, it's quite interesting. So first, after the demand shock, what we see is that the optimal monetary policy is every time able to stabilize more the economy in the sense that the output gap and the CPI inflation won't move that much after the shock, both in a risky or non-risky environment. But interestingly, with the supply shock, the optimal monetary policy is able to stabilize more the economy, but just in a risky environment, which suggests like maybe different kind of monetary policies should be used according to the risky context. So to conclude this slide, from our theoretical results, clearly the optimal monetary policy is better able at stabilizing the economy in a risky environment after shocks. But now let's see what happens in South Africa. As I told you before, we here estimate Markov switching model. So we use quarterly data from 1990 to 2019. The major part of the data are taken from the QPM. So we have the output gap, nominal interest rate, nominal exchange rate, and the CPI from the QPM. And then the PPI and the VIX are taken from Fred database. Then we estimate our new Keynesian model using Bayesian methods, allowing for Markov switching, following the method of Yu, Wagoner, and Zah. And what matters here is the way the switch in the two regimes will appear. So, as I told you before, we switch from one regime to another according to the risk that we here proxy with the VIX. So, to do this, we state that the VIX is equal to its lagged value plus a shock times volatility. So what happens is that the volatility of the shock is gonna make the model switch from one regime to another. So ST represents the two regimes. ST equal 1 is the low volatility regime and ST equal 2 the high volatility regime. And the regime is gonna switch when sigma t reach a certain threshold. So when the volatility of the shock is big enough. Okay, so this switching comes from the data. Everything is data driven. So you're gonna see the result in a bit. So now what we're gonna look at is whether there is switching in regime, because you can try to estimate Markov switching, but it never switches. But here, luckily, it does, fortunately. Just here, focus on the second graphic. It's symmetric, so it's just confusing looking at the two of them. So what happens here when there's spikes and it reaches 1, it means that we in the high volatility regime, so crisis regime, with 100% probability. So clearly here we reached this high volatility regime in 2008 with the crisis, and around 2012 after the European crisis and all the quantitative easing monetary policies which has been done after this. So our model is able to capture this. Then we have two other spikes which doesn't reach 1, but still they are here. And obviously at the beginning of 94, it's the end of the apartheid. And in around 2001, it's linked to the Asian crisis. So clearly our Markov switching estimation is able to capture this crisis period, and it makes sense with the dates. So now let's take a look at the results. What is important here to look at is the mode of the posterior, because this is our estimated values. And first, concerning sigma gamma, that's what makes the switch in the regime, what I told you before. We see that the low volatility regime, this standard deviation, sorry, is 0.068, and we're in the high volatility regime when it's 0.138. But what's interesting here, so we are the parameters we estimated. So first, gamma pi and gamma x are the parameter of the monetary policy. So clearly here, the Taylor principle is not respected, but it makes sense, I mean, for inflation, because the central bank should also react to expected inflation and probably other variables. That's why it's so low here. Then concerning beta, it's almost 0.99, so it's there's not so much to say about here. I guess it's normal. Gamma and sigma represent the intertemporal elasticity of substitution between leisure and work and consumption and saving. They are close to 1, so it's not really striking. It's not a bad result. And at last, alpha, as I told you before, is represent the degree of openness of the economy. And if you go back to the micro foundation of the model, this alpha represents the share of consumption allocated to imported goods. So if you want to link it to some data or something happening in reality, it should be roughly equal to the import to GDP ratio, which is approximately 30% in South Africa. So our 0 to 34 is quite nice. It's close actually to this GDP to import ratio. Okay, so that's what I have to say about the parameters. Now we take these parameters and simulate again a demand and supply shock with our theoretical model in order to see what would happen in South Africa after a shock if they would have used the optimal monetary policy, because as I said before, it's the one which stabilizes the most the economy. Okay, just the differences between the parameter in the reaction function, the optimal monetary policy, between what we calibrated and what we estimated. So the thing to say here is that with the estimated value, the central bank responds more aggressively to all the variables to set the expected inflation actually. And gamma E is the response to the current exchange rate, and E1 to the expected exchange rate. Okay, so now let's take a look at the results. So here is the demand shock. So we have the demand shock, the gap increases. So the central bank is going to increase the interest rate. And this increase in the interest rate is quite large here. So the incentive to borrow abroad increases, and the financier is long in the domestic currency. So what we see is that we have a large depreciation in the exchange rate, followed by an appreciation. The red line represents the risky period, the crisis period. We see that the depreciation is really larger, which increases far more the CPI and the interest rate. Okay, so that's the case of a demand shock. And here, what we can say about this reaction function is that the optimal monetary policy is really not able to maintain exchange rate volatility after the demand shock in crisis period. Concerning the supply shock, once again, blue is low risk and red high risk. After the shock, the domestic inflation increases, so the interest rate increases as well. And again, the country borrow from abroad, so the financier is long, so we have a depreciation followed by an appreciation. And the larger depreciation in the risky environment increases CPI even more. It's quite as before. And again, we can conclude that the exchange rate movement after the shock are still really large. So this optimal monetary policy is really not sufficient, which suggests the use of other tools to tackle this problem of exchange rate volatility after shocks in a risky region. So in conclusion, as I said in the beginning, capital flows could destabilize emerging economy. So we model it through a new Keynesian model in which the exchange rate is driven by position and risk in the foreign exchange market. Our model is able to reproduce the fact that indebted countries see their currency depreciate and countries receiving capital see their currency appreciate. Our theoretical results suggest that the monetary policy has the ability to mitigate the stabilizing effect of capital flows. And according to our theoretical result, again, in a risky environment, an optimal monetary policy brings more stability due to the fact that it responds to exchange rate movements. And at last, through our empirical investigation, we conclude that this optimal monetary policy is not sufficient for South Africa to avoid large exchange rate volatility in a crisis period after shocks. So thank you for your attention. That's what I wanted to tell you.
Thank you very much. That's some really great research. I see we have, and there's definitely feedback from our attendees who agree. So are there any comments from anyone in the panel? Anyone?
I shouldn't ask a question on my own paper, but no, just maybe to clarify for everybody. When if you go back,
yes,
if you go back to the last two pictures, the two impulse response.
Yeah, I'm trying. I have a problem with my laptop. Okay. Yes.
Yeah, these one. These what is interesting? Yes. Sure, Hilton, you can ask a question. I just pointed out one thing. What we are able to do with this is really to explain a lot of out of equilibrium exchange rate volatility. Therefore, this one is exchange rate volatility that is driven by the extra premium that you had to that the financier, sort of this oligopolistic market, with financier as essentially price maker, and they can therefore ask a higher return during risky period. Therefore, if you want to have access to capital market, depending what the period is, the effect on exchange rate and therefore the effect on the economy will be much higher. And therefore, you have all this extra volatility. There is also a volatility inside. Therefore, if you look, for example, this demand shock, I think is quite a good example of this. Demand shock here hasn't got an expansionary effect. Demand shock here has got straight away a contractionary effect, because the effect on exchange rate, because demand shock, it means that you need more imports relative to export. Therefore, you need to have more financing to finance the difference between demand and supply in the economy. But in period of high risk, what you have is that you need to give a much higher return to the financier for this finance to come. And therefore, you will have a much bigger devaluation now, and therefore a much higher revaluation in the future. This big the valuation has got an effect on CPI, for which the monetary policy respond with an increase in interest rate. Therefore, as a contraction in domestic inflation, therefore you are substituting a much bigger imported inflation towards the domestic inflation. Therefore, I think it's interesting for us thinking about when you abandon the UIP and the nicety of UIP, then you find all these first different regime between when you have an external environment that is very volatile, or an external environment that is very calm. These affect the way your own policy affects your own economy, in that sense. Because anyway, your policy is dependent by your ability to finance. Therefore, that one is one element. The other element is what Cyril was saying. Having one instrument only is not sufficient to also deal with this excess volatility. We haven't explored any other instrument, but I think, for example, the work of the work of how to use quantitative easing, or even the experience of the intervention in the bond market in the last shocks point to some way of analysis. And with this, I close. Now we have two questions.
Okay, thank you. Yeah. So, Hilton, you also
Yes, thanks.
have a question.
Fantastic. Can you hear me? Yes. Great presentation. Also very interesting. I've started looking into the same approach for the financiers. I think it's a nice way to marry, just what Nicholas said, some of that excess volatility you see in the South African exchange rate, kind of bringing it into the macro model. So it's nice to see that. Just one or two maybe concerns I want to flag, and then just some two questions. Looking at, I think it was alpha was the degree of exchange rate pass through to inflation. This was about 0.35, so that's about 35% pass through. I think that's quite high, but I stand to be corrected. I think in South Africa it's much lower, about 10%. So maybe some of the reserve, Nicola would know this. I would like to comment on that. And I think that, it's not obvious that this pass-through will be constant through these different states. So exchange rate pass-through may also be state contingent on the risk-bearing capacity of financiers. Because this is important, right, for the policy analysis. For me, you're saying there's this pass-through, it's constant, and then monetary policy adjusting, but it actually might be that the pass-through offsets that when the risk-bearing capacity is low, and etc. You get the point. So I think you might actually be modeling something that doesn't exist or doesn't happen empirically, at least, or what we observe. Just maybe a comment on why you included PPI as an observable variable. And then another comment on whether or not, I'm sure this is obvious, but the correlation between VIX and the bid-ask spread on the Rand exchange rates. So when VIX volatility is high, I assume it must be very strongly correlated to wider bid-ask spreads on a Rand exchange as well, because that would then justify the link. It makes sense though. And then you emphasize trade financing. And I think, this is also something that's not always included in our macro models. But I'm just wondering again, there's still some debate. I don't know all the literature or anything, but just what I've read that of how important trade financing is, especially for, current account movements or external adjustment. and some recent work, I think, by Michael Kumhoff, talking about where most of the observed cross-border flows are related to globally, as well. Globally, they're looking at as well, but are related to debt refinancing and financial intermediaries. So, this massive increase in cross-border flows, that's also fueling a lot more of the volatility in the exchange rate that we are observing, is not so much got to do or linked to trade financing. So and it's more to do about how financial intermediaries are accessing global capital markets and how they're rolling over their debt. And so I'm just wondering, how in these two environments, a financier would kind of face different set of concerns. They're not necessarily, they don't necessarily need to hedge contemporaneous exchange rate volatility. They're also maybe linked directly into contracts that are more longer term, that have more smoothing. So I'm just wondering if you've thought a bit about this, the role of trade financing, maybe the role of trade financing in South Africa versus, other ways of modeling this relationship. Thanks,
Okay.
but a very good presentation.
Thank you for your comments. So, okay, should I answer? Yeah, I answer now the question. So, first concerning alpha, empirically, for what I understood from the microfunding model, it's what I said before. It's like the import to GDP ratio, which is almost 30% in South Africa. So I think it's quite okay, but maybe I don't know. As I thought in the beginning, it's really in progress, the empirical application, and obviously we should go to something where the parameter can switch from one model to another and estimate it, because obviously it makes sense, and I think it would be great to do it. Your second question was about the PPI, why I use it. It's just for the domestic inflation, actually, to have the domestic inflation. I use the PPI. Does it make sense?
No, okay. I was just wondering, because you included two measures of inflation, so I was just wondering.
Yeah,
if there was
that's for
reason. Normally, it's linked to a specific shock. So you have your typical cost push shock, and then your Keynesian-Phillips curve. And I was just wondering, this was not import price inflation. This was producer price inflation, and then the CPI. So I was just wondering, if you were matching those observables to two distinct shocks or not.
Yes, the supply shock I make is on the Phillips curve, on domestic inflation, and in the CPI is the CPI, but the shock is on domestic inflation. That's a good question. Okay, the VIX here, the VIX. Yeah, I think actually. I don't know. I didn't check if it's correlated with the risk in the rand, but probably yes. I'm pretty sure that it is. And taking the VIX here, I think it's quite interesting, because with all these crisis periods we have, obviously the economies like South Africa, when the global risk increases like this, and in large economies, it will obviously go through South African economy, and it will affect the financial markets and whatever. So I think it's a nice proxy for the risk here. But maybe we could, I don't think, to include another one, maybe, I don't know. But anyway, I think the VIX is okay and should be correlated with the risk in rand. And for the trade financing, what I know that the capital flows are huge, even in South Africa, and in my mind, it's quite obvious that it will affect the exchange rate. This huge capital inflows, huge trading, and maybe in the short run, yes. But anyway, I think there are work to do on this, and I have some ideas of paper actually to look precisely empirically what happens with these capital flows. I was thinking of using order flow to see whether it really affects the South African economy or not. But like this, my intuition is that obviously it should have an effect, but I can't tell you exactly what's happening. I need to check. So hope you okay with the answers, and thank you for the questions.
Thank you.
Okay, thank you. We also have a couple questions from our attendees. Guangling says, I'd like to know, what is the definition of risk in your model? And then his second question is, you express or emphasize that exchange rate movements depend on the demand for imports. What about exports? What is the reason that a supply shock is driving output gap to decrease? And just one last question, perhaps also report or consider how CA imports and exports react to demand and supply shocks. So those are some questions.
Okay. Okay, for the risk in the theoretical model, I mean, it's what you guessed. Yeah, I'm sorry, I forgot to tell it. It's the gamma, the risk bearing capacity. We just here take two. It's like a parameter. It's a constant. We take a really low value close to UIP and a higher value. It's just two different values. So it's not homogeneous at all. I should have told it. I forgot. I'm sorry. So your question totally makes sense. Then what's the other question? Supply shock. The supply shock, it's because it increases. Are you talking about the theoretical model or this result with the estimations?
By both. Is a shock on the supply curve, is an increase in costs.
Yeah.
Cioè, it's not a productivity shock. It's a shock on the supply curve, cioè on the Phillips curve.
Yeah, that's it, and it decreases the output gap, and even more with the appreciation actually after. But yeah, that's the question of cost. And then. So sorry, what was the last question? I didn't get it. Did you
Last one, yes. Perhaps also report to consider how CA imports and exports react to demand and supply shocks.
The export here in the model, as I told you, we assume it, the export value equal to 1 to simplify the calculation. So we don't have export here, but it will just has the opposite effect as imports have if we homogenize it. And but I don't think in the theoretical model it's like relevant to do it. It will just make it more complex.
Okay, thank you. Very good presentation and great research. We really appreciate you sharing it with us. So unless there are any more questions from anyone in the audience or anyone from the panel, we can look at continuing.